Let's take a look at dichloroethene. This is a type of molecule that you might see as you go further in organic chemistry, or this is a very simple type of molecule like that we see. And it has two carbons, two hydrogens, and two chlorines. It exists as three different what we call isomers. There are different types of isomers out there. The ones that we're looking at here are structural isomers. Well, we have geometric isomers mixed in here as well, but don't worry about that. Just saying that they are different ways to put these together. So these are on different carbons here and here. This one's below the double bond, this one's above the double bond, and these are both on the same carbon. So we see the cis. Cis means they're on the same side, meaning they're both above or both below the double bond. Trans means they're opposite. I can spell. On opposite sides of the double bond, because the double bond restricts the rotation, whereas something that has all single bonds is free to rotate. The double bond does not allow free rotation. That's all stuff that will help you when you go further in organic chemistry. But what we're going to look at right now is, are these molecules polar? So we can actually look at this in larger molecules and see what our dipoles do. So we're going to draw dipoles from carbon to chlorine because carbon is 2.5, remember, and chlorine is 3.0. So that gives us an electronegativity difference of 0.5, which is polar. And we see one there, and we see one here, and they are going to add together to give us an overall dipole that looks something like this. So we don't really need to know what the number is. This number is going to end up being 1.9 when we look at this on the screen here. Okay, there we go. So this is the dipole moment, and it is polar because we do have an overall dipole, giving us a boiling point of 60.3 degrees. When we look here at the trans one, where they're opposite, we see that this dipole moment actually cancels out. So both of those are facing opposite directions. They're going to cancel each other out. This is going to be nonpolar, so the boiling point is going to be lower. So when we take a look at that boiling point, we're going to see that it's going to be lower. Now we look at the one where they're on the same carbon, and we see these two going in opposite directions. It's going to give us an overall dipole that looks something like this. And we're going to see a dipole moment of about 1.34. So that boiling point being about 31.7, having both those chlorines on the same carbon definitely changes the overall boiling point, making it much lower in this case. So how does boiling point change based on, how do the physical properties of a molecule change based on its overall polarity? That's what we're going to look at more and more in this chapter. So intermolecular forces. Intermolecular forces